let's look at how we can use GeoGebra to analyze the derivative of a function, right? So in this section, I'll use the function f of x. So we come to the command window, f of x equal to negative 0.25 multiplied by x minus 1 multiplied by another x plus 1 and then multiply by x plus 3. Then when you are done, you press enter. So this is the function in GeoGebra. So now let's create a slider for it. So we create a slider. We can do it in two ways. First of all, we are doing a direct derivative. When we are done, we will use that same approach to check whether derivative exists at a point or not. So in doing that, you go to sliders, you select sliders, you click anywhere, and now you want our name to be A, and then since the name to be A, let's maintain these ones, but we can make the increment to be maybe 0.1. It depends on how do you want to do it, right? So this, it depends on how you want to. You can make the increment to be any one that you want, right? So when you are done with this, the next thing that I need to do is to connect this slider to the function. And in connecting this slider to a function, what you need to do is that into brackets, the slider name is A, and then comma, and then you bring f of A. So when you are done like this, you press enter, you can see that there will be a dot or a point roaming on the function. So when you are done with this, before you can analyze the derivative, you need to get a tangent line. So in doing that, you have a command in GeoGebra called tangent. You type tangent, you see tangent, the second one point, or maybe the first one point and conic, or point and functions, right? So a point and a function. So you click on a point and a function. The point here is going to be the point that we have created over here, which is A, right? And then the function is going to be my f of x, right? The function is going to be my f of x. You can use the conic, it also works same. So this is how it's going, right? This is a tangent for when you are done with this, you can just do slope, and then the slope, you select the first one, and then you enter the line, right? So what is the line that you are using? Now our line is G of Y. So our line is G of Y, and you click enter. So with this, you can see the slope down there. You can see the slope is 0.97 at a point, right? As you go, you can see how it's changing, right? That's how the slope behave. As you go, you can see how it's changing. You can see how it's changing. You can also do it in a different way. That's now we are doing analysis to see whether the derivative exists at a point, or we can find a derivative at a point. So let's say that we should analyze the derivative at x equal to maybe 5. At x equal, let's say at x equal to 2. Let me say that way. So at x equal to 2, we need to create 2 sliders. So the first slider will have minimum value should be, maybe we are creating for the left-handed limit, right? The minimum value can be -2 or -3. The maximum, since we are approaching 2, it should be 1.999. Then the increment should be 0.1. It's okay. All right. So because the rounding is less than 1, you need to go to options round, and then you go here, you can change it to 5, and it will appear 1.99 over there. So now we are done with this. Let's create for the right-handed limit. So when you create for the right-handed limit, you go to slider, you click anywhere. We are maintaining the name to be C, and then, or let me say B, and then since you are approaching 2 from the right, our minimum should be 2.001, the maximum can be 5, and then the increment can be 0.1. Then you click enter. Right, so the slider has been created. So for this, we are also going to connect this one. We're going to connect this one to the function. In doing so, we have into bracket b comma f of b, and you click enter. Right, you can see there's a point roaming. Now let me shift it up there so that you can see the points on the function. Right, so you can see the point on the function. Yes, I hope you can see the point on the function. Yes. So now that I'm done with this, let me create a tangent for it. So tangent line, you type tangent. Right, you select the function, so the point and the function. So the point that we created now is what? B, and then the function should be f of x. Right, so now we have 2 tangent lines. You get it? 2 tangent lines, 2 tangent lines from here. Yes, you have 2 tangent lines from here. Yes. So with this, what we can do next is find the slope. Therefore, you type the slope, then you select line, and then the line should be our h of y. H of y. When you are done, you click enter, and now as you move the slider, you can see the slope. Right, so let's see the slope here. The slope for C asks, okay, the slope for C asks the slider moving towards 2. Towards 2 is negative 6.2 something something, and then when you do this same for 1.99 is negative 5.7, which is approximately approaching 6. Right, so we can do it from, you can see it from here. Right, you can also do it using table to find out the value that is approaching. So if they are not approaching a common, their slopes are not approaching a common value, it means that the derivative does not exist at that point. But if they are all approaching, both the left-handed derivative and the right-handed derivative are approaching the same value, or the slope are approaching the same values, then we say that derivative exists at a point. Thank you. And then if you have any question, go to the comment section and then ask your question. And in my subsequent videos, all your questions will be addressed. Thank you for watching, and see you in my next video.